Hello everyone, this is Dr. Suganya, Associate Professor from the Department of Computer Science at Dr. SNS Rajalakshmi College of Arts and Science. Today in this video, I am going to share about the key concepts in robotics. So, robotic software architecture, which forms the backbone of how a robot perceives, decides and acts autonomously. So think of this as a blueprint of autonomy, defining how different the software components interact with the complex robotic system. So let's now see about the definition or introduction about the robotics. So robotic software architecture defines how the software modules are structured and communicate with one another. So it establishes the logical organization of sensing, control, decision making and communication components. So ensuring that all parts of the robot work together without any harms. Next is about the structural foundations. So the architecture provides a strong foundation for core robotic functions such as the control systems, environment perceptions, complex planning, etc. So just like how a building relies on its structural design, a robot also efficiently and intelligently depend on its software architecture. So let's now see about the blueprint, that is analogy. So the architecture acts like a blueprint that dictates how the sensors, actuators and algorithms communicate in real time. So for example, sensors used to collect the data, decision modules interpret that data and actuators actually execute the commands. So every layer must interact smoothly to achieve the real-time intelligent behavior in the robots. So the next slide is about why the software architecture is critical in robotics. So the software architecture is essential because it ensures modularity, scalability, performance and reusability. So modularity, that is the components can be replaced or upgraded without affecting the entire system. So when we speak about the scalability, the new sensors or the functions of a robotics can be added easily. So the performance, the system becomes more reliable and responsive. So when we speak about the reusability, the validated code modules can be reused across multiple platforms, saving the time and cost of the development of the robot. So in short, a good architecture keeps the robotics developed, organized, efficient and future ready. So in this slide, we are going to see about the core components of a modern robotic systems. So there are some key elements like sensors, actuators, control systems, middleware and user interface. So sensors are mainly used to capture real world data such as distance, vision or force, and actuators are mainly used to convert the commands into a physical movement. So the control system actually acts as the robot's brain. So it is a central part of the robot, handling the decision making and tasking, also for planning the movement of the robot. Next is the middleware, which is used to serve as the communication bridge between the software and the hardware, which is used to develop the robot. Next is the user interface. It always allows the humans to monitor or control the robot effectively. So together these all components enable the perception, decision and actions of the robot, and they are the pillars of the robotics. So in this slide, we are going to see about the foundational architectures. So totally we have 4 different foundational architectures like reactive architecture, deliberative architecture, hybrid architecture and behavior based architecture. So reactive architecture is fast and direct. So it is response actually very fast and very accurate and directly. So deliberative architecture involves in planning and reasoning. Hybrid, which combines both the reactive and deliberative features which we saw above, and behavior based architecture, so it gives the multiple behaviors compete for control and each has its strength and it is suited for specific robotic reactions. So now let's see about the reactive architecture, so which is specifically means for its speed and simplicity. So in this reactive model, robots act directly on the sensor input without the internal reasoning or planning. So they work on a simple stimulus and response based robotics It is fast, but it is very limited only. So for an example, let us see a line following a robot instantly adjust the motor speed based on the sensor reading. So what will be the advantage means it will be extremely quick and computationally it is very light. And equally it also has the limitations like it lacks long term planning and we should be very strategic while decision making. So next is about the deliberative architecture, that is an intelligence through planning. So this model introduces a word model like an internal representation of the environment, and the robot plans before acting, predicting outcomes and choosing the best path. Used in the autonomous vehicles or planetary rovers, and this approach is intelligent but it is slower due to the high computation needs. It is ideal when the precision and reasoning are most important than speed. Hybrid architecture, so it is the best of both the worlds. Like hybrid architecture balances the planning and reaction. We have three different layers like upper layer, intermediate layer and lower layer. So upper medial, which is used to handle long term goals and strategy, and middle layer which handles the breaks. The breaks can that is the huge tasks can be break into different sequences, and the lower layer which reacts instantly to changes. For example, a delivery robot can plan its path but still avoid the obstacles in the real time. So this design combines the best aspects of the both deliverable and reactive robotic systems. So next we are going to see about the future of robotics, where the modern robotics relies heavily on the standardized frameworks like ROS, AI-driven architectures and cloud robotics and edge computing. So the acronym of ROS is the Robot Operating System, which provides modular tools and libraries and communication interfaces. And AI-driven architecture mainly uses the machine learning to adapt the changing environments and dynamically. So cloud robotics and edge computing, which combines the features of the powerful cloud and it processes with fast local edge decisions and efficiency. And these are different trends that are used to shape the future of intelligent and autonomous robot to develop. So thank you. So let me conclude this video by telling about the foundation for autonomy, like robotic software architecture. It's not just about the coding, it is about designing the intelligence. So it defines how the robot perceives, reasons and acts. So forming the foundation of an autonomy, as we study about the robotics now in this video, we continue to evolve the artificial intelligence and edge computing, understanding the software architecture, and it also becomes the essential for building the next generation of intelligent machines. Hope this video is useful for the students. Thank you. Let me catch you in the next video.